All right, so here are your last notes for Chapter 7, 7.5. We're going to deal with parts of similar triangles, and we are still going to be dealing with proportions as well. As always, your warm-up, you're going to do on your own, referring back to our previous lesson notes, and we'll go over it in class. We're going to learn a few more terms here, dealing with our special segments that we've learned, and how they correspond, and we can set up proportions to find missing parts of similar triangles. The first one is your corresponding altitudes of similar triangles theorem. So this is going to state that we have two similar triangles, the lengths of corresponding altitudes. So now we're dealing with your altitudes within the triangle. These corresponding altitudes, or matching altitudes on each triangle, are going to be proportional to the length of corresponding sides. So here we have two similar triangles. What we're doing first, we're seeing here that we have segment AD as an altitude. It is going to be set up to a ratio of segment FJ, the other triangle's altitude. We can set these equal to, saying that they are proportional to any two corresponding sides of these similar triangles. In this example, they chose side AB to set up with a ratio with its corresponding side FG. Now what I do want to show you is you can grab any of the three sides here using those altitudes. So I'll give you one of the other two examples. We can use segment AD right here, our special segment, our altitude AD is to our other altitude FJ. And we can actually set that equal to, let's pick a different side. Let's say here, side CB and side HG. You can also set these altitudes equal to AC and FH. So there are three different ways we can set that up. The next one is going to be your corresponding angle bisectors of similar triangles theorem. So now we're going to have two triangles that are similar. The lengths of the corresponding angle bisectors. So instead of it being altitudes, you're going to see your congruent angles, angle bisectors. They will be proportional to the lengths of any two corresponding sides. So again, just to make it easy, we're going to start off with LP, which is your angle bisector. We know because we have two congruent angles. And we're going to set it to a ratio of the other angle bisector, RT. On the other side of the equal sign, setting it proportional, we're going to pick any of the three sides that we want to. So here we have LM, which will be right here, and it will correspond with side RS over here. Now notice you have to stay consistent in this first ratio. LP came from this, what we can see is a smaller triangle, and the bigger triangle's angle bisector went on bottom. So when we went to the other ratio, we had to go back and keep the smaller triangle on top and the bigger triangle on the bottom. The next one is your corresponding medians of similar triangles theorem. So same thing, we're just changing the different kind of segments. Okay. Here we have, if two triangles are similar, the lengths of the corresponding medians are proportional to the lengths of corresponding sides. Okay. Now here, there's something a little different that's going to change with the medians. I'll show you after we look at a couple sides, because the fact that we have these midpoints, point D and point Z are midpoints, creating two congruent segments, we're going to see something a little different. But let's start off with, what we've talked about here. We've got our CD, which is going to be our median. How do we know it's a median? Because we have a midpoint. It's going to be set up to a ratio of segment YZ, our other median. This will all be equal to, and it doesn't matter which of these three sides you choose, okay? This one, they had AB right here over WX right here. Now the great thing with your median is you actually, if you have AD and WZ, you can just use part of those sides. What I mean by that is we still use our medians. CD is to YZ. We can actually set that equal to just part. So we could say AD to WZ. simply because AD and DB are equal. So that's the only reason we can do this with a median. Okay, you cannot do that with your angle bisector or your altitude because the parts down here are not the same. But here it's a special case. Again, just kind of what information do they give you. The last one, I want you to notice the picture. One single triangle. So your triangle angle bisector theorem is going to be different parts of this one single triangle set up proportionally. What I mean by that is we're going to have an angle bisector. How do we know? Because we have two congruent angles. In a triangle, it's going to separate the opposite side over here into two segments. We can see that, KM and ML. Nothing to do with them being equal. Nothing about them being congruent. But it's going to separate into two different segments. These two segments are going to be proportional to the other two sides. I'm going to use 4 colors here to help you guys see exactly what's going on with these letters. We are no longer using the angle bisector in the proportions like we did in the previous 3. Because the previous 3 we had 2 altitudes, 2 angle bisectors, 2 medians. Now we have 1 angle bisector. So we're doing little parts proportional to each other. So watch how this works. We're first taking KM, which you notice is right here. Okay, so we're going to take KM. We're going to set it up to a ratio KM to LM, which is the other part. I can't say they're the same, but it's the other part of that segment. Okay, so little part plus little part, or sorry, I'm doing addition now. Little part to little part of that one side. We're now going to set this we're going to set this equal to here KJ, which is right here. Notice I went back to the side that is right next to my original segment. KM right here touches KJ, so I want to keep those together on top. And then it's going to be, we're going to set KJ to LJ. Oops, wrong color. Grab my purple. LJ right here. Okay, so again, what's on the bottom stays on the bottom. So we have this little part, my little red right here, touching the purple, okay, and the blue touching the green. You don't want to go blue to red and the purple to green. You're skipping around, okay? So we're going to go ahead and start going through some practice problems. You're going to notice a lot you're going to be solving on your own. No big deal. Once we get through this, it's going to be consistent. It's going to be almost the exact same thing over and over again. So the first thing we see here is, given that these triangles are similar, we're going to find the value of x. First, we want to write a similarity statement to remind ourselves what this looks like, okay? So we're going to say these two triangles are similar. So let's name our first triangle. I'm going to name it triangle KLM. Now when I name the second one, I have to keep my corresponding angles together. K had 1 arc. It's going to correspond with X over here with 1 arc. L, my middle letter, had the 2 arcs. It's going to go with Z. And then M had no marks, and Y has no marks. And how are these similar? Well, take a look at what we have. Look at just the outside triangle here. Okay, we're not worrying about that, what we're going to talk about in a minute, that special segment. We're just looking at the outer triangle. We're going to notice we have a congruent angle here, and we have congruent angles here. So these two are similar by your angle similarity. So let's talk about the special segments so we know how to set this up. The special segments right here, this is what we're going to fill in here, segment what and segment what. Well, here we have segment MP and segment YQ, keeping my corresponding parts together. They are what kind of special segments? Well, let's go back to first semester, the very end of first semester. What do I see there? 90-degree angles. That tells me we have altitudes. So these are going to be altitudes. So when we set this up, we're going to go back all the way up to this very, very first one, and we're going to set up our altitude, a ratio of each altitude first. So here we're going to take our ratio of altitude MP to the ratio to our altitude YQ. We are going to set this equal to, proportional to. Now, we have to pick a side. In some cases, they only give you one option, and here, that's what they've done here. We have here Km, that's our other number here, so Km. Now watch when I set up the other one. K was at the angle that had one arc, going to M, so we have to keep a corresponding parts. So we're going to go from X to Z. Now we will substitute in. MP, right here, we saw was 16, over YQ was X. We will set that equal to Km, right here, was 20, over, what would we say, Km, so XY, 15. We've talked a little bit about with the proportions and simplifying the fractions within the proportions to help you deal with smaller numbers. So what I want you guys to see, I'm going to show you guys here, again, simplifying 20 over 15 to give us smaller numbers. Well, 5 goes into 20 4 times, 5 goes into 15 3 times. So we can simplify it and now use 4 over 3 to cross multiply. We'll cross multiply x times 4, giving us 4x, is equal to, cross multiply 16 times 3 is going to give us 48. And then simply divide both sides, and x comes out to 14. Okay. The next part that we have here, number 2, we're going to take a look at the fact that these are similar triangles, and we want to know what the special segment is. We only have one triangle here, which is going to bring us back to one of our theorems. But here we see that we have congruent angles in this, congruent angles, so we know that this segment is going to be an angle bisector. So with your angle bisector, there are 2 of them. One dealt with 2 triangles, one only had 1 triangle right here. So this is what we're going to be doing, parts. So the first thing I'm going to do is I'm going to kind of use my colors, and I'm going to label the 24 with one color. I'm going to label my 18 with another color. Here, my 2x plus 1 with a third color. And then my 3x minus 1 with a fourth color. So how I'm going to set this up is I'm going to do the 24. I'll do it exactly like what we had in the notes. I'm going to do my 18 over my 2x plus 1. So we have our part over our part. So 18. I'm going to have my proportions set up here. Over this part, 2x plus 1. And then my full side back up here, 24, over the full side down here of 3x minus 1. Now at this point, yes, you will have distribution. I understand that, but I want you to go ahead and finish this out and solve for x. Number 3, again, we're given that these are going to be similar triangles. So what we're going to do first is we're going to identify the similarity statement. So here I'm going to name the first triangle, triangle TSR. And I'm going to say it's similar to triangle. Well, I went from 1 arc to 2 arcs to no arcs. So I'm going to go from 1 arc, W, to 2 arcs, V, to no arcs, U. And again, just like the other one, I see congruent angles here, and I see another pair of congruent angles here. So we have it by the angle-angle similarity. So we have 2 different special segments here. We have segment TP and segment WQ. And what are they? Well, let's see what we have here. I see congruent markings down here dealing with a midpoint. So point P and point Q are midpoints, giving us medians. So when we solve for x here, we can set up our proportion already using our medians segment. We got TP over WQ. and we will set that equal to, saying it's proportional to, well, let's look at what we have. We have SP and we have UQ, okay? We don't have the whole side. You have a couple options here. You can either double it up and get 2x and 6, or with medians only, you can actually just use the part here. So then I can say SP over, now S corresponds with V, P corresponds with Q, so we'd actually have VQ. Problem is VQ isn't labeled, but VQ is congruent to UQ. So this is also 3 because of these little congruent markings that we have. Okay? So what I'm going to do now is I am going to let you substitute in and set up your proportion to solve for x. Okay, so we'll go ahead and do the substituting and solve for x. The word problem is very long. Don't get too overwhelmed with the words in this word problem. I'm going to help walk you through it and understand exactly what's happening. Here are Liliana's eyeballs, okay? She's going to hold her arm straight out in front of her, the elbow straight, and her thumb pointing up, closing one eye. She's going to line one edge of her thumb with a car inciting. Next, she's going to switch her eyes without moving her head or her arm, and the car appears to jump 4 car lengths. Okay, so here's that, here's one car, here's the other. It's going to jump 1, 2, 3, 4 car lengths. Her arms are about 10 times longer than the distance between her eyes. So what that's talking about is here, the distance between her eyes and her thumb is 10 times longer than the distance between her 2 eyeballs. Well, what times 10 gives you 10? 1. So that tells you that right here, the length between her eyeballs is simply 1. Okay? Now over here, we are told that each car is 5.5 feet. Well, not including this car, but here where we start, we're going to have another 5.5 right here. We're going to have another 5.5 right here, and then your final car of 5.5. So what this ends up being is 4 car lengths of 5.5 each. Multiply that by 5, you're going to get 22 feet. So that's going to be the total length of right here. It's going to be 22. So we set this up. We have 2 separate triangles, ABC, and we have DCF. We have our 2. What are these going to be? Altitudes. Right? So we can set up our altitudes of CQ is to our other altitude, CP. Set that equal to our sides that we have, AB, to DF. And now we just substitute everything in. CQ was 10 over CP of X equal to AB was only 1, and DF over here we've calculated was 22. So you will go ahead and solve this one on your own and find X. Our last examples here. That's the wrong one. I kind of just gave you what we're doing. It actually doesn't even give you that much. Here's the blank one. All right. We're going to identify these special segments and then do the exact same thing that we've been doing. Here we have special segment. How do we only have one triangle. There's only one of the 4 we talked about, and that would be the 2 congruent angles. We have an angle bisector. So now we're going to solve for x. With the angle bisector, this is where we did our part over part is to the whole side over the other whole side. Okay, this is the one triangle, the 4 different colors. Problem is, We don't have this section right now. So what we have to do is take the whole side of 54, subtract that 28. So your 54, subtract your 28, you're going to wind up with 26. Okay? So this entire length right here will be 26. So I'll help you guys by just setting it up, and you will solve on your own. Yes, you'll have some distribution. So I'm going to set up the 26 right here over my 28, part over part. We'll set that equal to, say it is proportional to. So the blue goes with the green up here, so the x minus 5 to x down here. You will go ahead and solve for x on your own. Now, good news. Number 6 and number 7, you're doing on your own, and we'll go over in class. Okay, you can do it. Look at the pictures and look at how we're going to set our proportions up. And we'll go over it in class the next day.